I suck at quicksort algorithms, but they are used to, well, quickly sort through a given list. Quicksort selects an element from the list to be used as a pivot point. Then, all the remaining items in the list are partitioned into two sublists based on the pivot point. The sublist consists of elements that are less than the pivot point or greater than the pivot point. The quicksort function is then recursively called to sort the sublist. This process is repeated until all sublists are sorted. Then, the lists are combined to a final sorted list. In this example, there's a list of 10 numbers in random order. The first number in the list is selected as the pivot, and the remaining numbers are sorted as less than the pivot or greater than the pivot, and placed in separate sublists. The pivot and sublists with length less than or equal to 2 are not called on again, while the list with a length larger than 2 has a new pivot that is selected and the remaining numbers sorted based on that pivot. This is repeated until all sublists are sorted. Then, all the sublists and pivots are combined into a sorted list and returned. An example of a quicksort function is shown, with the following function receiving an array. The base case of the array is being checked if the length of the array is less than or equal to 2 and will be returned. If the base case is not met, the recursive case is called, a pivot is selected from the array, and the remaining values are sorted as being less than or greater than the pivot. The quicksort function is then recursively called until all subarrays reach a length of less than or equal to 2 and are sorted. Then, the sorted lists are combined and returned. Quicksort has a big O notation of n times the log of n.